I'm Michael, and together with my buddies Hussein, Yusuf, and Arnav, we created a 3D graphical interface to explore interplanetary file systems. First, we created an IPFS scraper using Estuary to facilitate the connection. The decentralized peer-to-peer architecture of IPFS allows for anyone, anywhere to download files stored on the network. We're able to scrape the content IDs of 69,512 files, which is a lot of information to parse through. So, we wanted to develop a method of aggregating all this publicly accessible information and provide a compelling visual representation for exploration. This is where Cohere's Embed platform comes in clutch. Embed uses natural language processing to categorize and discover relationships between data, which is exactly what we need to generate a compelling visualization of files. In our case, for each file we retrieved off of Estuary, we combined the file's metadata into a sentence, and then plugged those sentences into Embed. From Cohere's API, we got high-dimensional vectors that modeled the relationship between each file and the others. The metadata we used included the file name, type, size, and date created. We really wanted to incorporate the actual file content into the sentence, but we didn't have a convenient way of translating various different file formats, such as images and videos, into text. So that's something we're looking to further explore in the future. Sticking with the Cosmos theme of IPFS, the visualization we created was a 3D collection of nodes, each with a gravitational force attracting each other, with each file pretty much being a planet. We color-coded planets by file type, represented varying sizes by differences in volume, and connected clusters of planets together with lines. Now, Yusuf's going to give you a walkthrough of our finished product.
Okay, here's a demo of our application. As you can see, each node has a different color based off the file type. You can filter on the right side here. Here's our logarithmic scale. And let's say I want to look at this MP4 video. I can right-click it. It'll zoom me in on it. And then I can press it. And it'll redirect me to the video.
Hi, I'm Hussein, and I developed a network scraping infrastructure of Estuary's API in Go. We chose Go for its concurrency model, optimizing the retrieval of data. We run tasks concurrently, limited by a token-based semaphore channel. This way, a new task can benefit from the waiting period of another. By requesting all of the miners on the Estuary network, we could access their previous deals, from which we are able to sift through the files involved, giving us access to nearly all network data. We used Python and 3JS.
The mathematics used in this project were for the purpose of feature reduction and clustering. To begin with, our Cohere embed model returned vectors, and each vector had 4,096 features. As this was hard to analyze, we had to use feature reduction in order to end up with 3 features which are easy to visualize. Now, in order to do feature reduction, we used principal component analysis. This form of feature reduction is known for being able to maintain as much information about the data as possible while reducing the number of features. In addition, we used clustering. Now, we used a k=2 nearest neighbors algorithm, and this algorithm was able to identify which points in our 3D space were close together, and thus which files had similar contents.
Visualizing big data is hard. We created IPFE to address this complexity and create an intuitive interface for exploring vast IPFS networks, and we'd love for you to try it out.